I'm sure many of you guys are asking what's a definite integral, and that's what this Pachachka service the purpose for is to let you guys know what a definite integral is. Many times in calculus, before you learn things, you're not very informed on what there is to learn. So here we go. Here is the algebraic nomenclature for a definite integral. As you can see, it comes from a Riemann sum, which is something that we've learned up to this point. And basically what the integral does is help you find the area under the curve. Here we go. Here's a graph of the definite integral, and here's the nomenclature. S equals the integral from a to b of f of x delta x. As you know, s is an arbitrary value that refers to the area under the curve between the values of a and b. A and b are your values of what you integrate with respect to. So in order to find your definite integral, you need to know how to find an antiderivative, which I'm sure all of you guys already know what to find. You need to take the antiderivative of f of x in order to find your definite integral, as well as you have to evaluate in terms of those. So here you go. Here's the antiderivative of a definite integral. This is a formula of which you find the antiderivative of a general function f of x. So you take the power, add 1, and divide by that number. Therefore, here you go. This is what your definite integral is going to result in looking like. And this is all general. This is just with letters, of course. When numbers are involved, it's a lot different. So this is what your ending evaluation should look like before you substitute in your concrete numbers. Delta x, I know you've seen this in many of the slides before, but basically all this says is the difference between a and b. So delta x is equal to b minus a, which is also equivalent to dx, which you will see in many other forms. And then here you go. Here's another picture of delta x. As you can see on the graph, delta x is the space in between a and b. So basically it's just a difference of your means of integration. Now you have to substitute your upper limit into your antiderivative. You substitute your upper limit before your lower limit because you want to make sure that everything you do is accurate. And in order to be able to find the proper definite integral, you need to be able to substitute in your upper limit before your lower limit into your antiderivative. And then you subtract the antiderivative with the lower limit substituted in. I know it looks like a lot. I know it looks like a lot of letters, but once you get to something more concrete, it makes it a lot easier, a lot less overwhelming to see. So the one main thing you have to remember is that you always substitute your upper limit before your lower limit. I know you're probably pretty overwhelmed, but we're going to give you an example of a more concrete example with numbers on how to help you out when it comes to integrating, because it looks a lot more difficult than it really is. So here we go. Here is the integral from 1 to 3 of x squared dx. And in order to evaluate this integral, you're going to go through the necessary steps that started from step 1. Here you go, you find that the antiderivative of x squared is x cubed over 3, and you have to evaluate from your normal limits from 1 to 3, starting with your upper limit, then your lower. And this is a more simplified version of your upper and lower limits substituted into your antiderivative, which is going to give you the area under your curve, which is what the purpose of a definite integral is. And as you can see, you just do simple math. You simplify, and then you subtract. And you get that a is equal to 26 over thirds, which is the exact value of the area under the curve of f of x equals x squared in between the x values of 1 and 3. So therefore, the area under the curve in between 1 and 3 on the x-axis is 26 over 3, and that is the solution to your definite integral. As you can see, it's a lot easier to do once you are more familiar with numbers and you're putting it in. And why are integrals so important? Integrals are important because they control a lot of things that people do outside in the workforce. They have a lot to do with engineering and physics, and parabolas are actually a big thing when it comes to architecture and bridge building, and you need to know the space under those. Integrals are used in many different extremely applicable ways. For example, an electrician needs to be able to do integral calculus in order to find wavelength. Over to the right is the equation for wavelength. As well as, you need, in order to find the volume within a bathtub or a pool, or to find the size of any sort of ball or anything, you need to be able to use an integral, because you need to find the area under the curve of a not so concrete place without straight lines. It's not like a square, it's more rounded off. So all in all, a definite integral results in a scalar and is used to find the area under the curve. It is very useful not only in school but outside of school when it comes to the work environment. So it's something very important to make sure that everyone knows.